Okay, good afternoon. This is Professor Forsyth, and we're going to begin our Test 1 review session. So I see I have one participant. Hello. If you could raise your hand or anything so I can know that you can hear me, great. Awesome. Okay, so what I'm planning on doing is I have some questions that are extremely similar to the test review on Blackboard, and I'm going to just work through as many as I can. If you have any questions while we are going through the material, feel free to stop me. I can unmute you and you can just say something. Um, Actually, let me think. I'm going to unmute you, but you can mute yourself back if you want to. I'm going to unmute it so you can say something if you want to.
Okay.
But you can mute it if you want, like until you want to say something.
Okay, no worries.
Cool. Okay, so let's see. All right, so we're gonna get started. Let me see here. Okay. All right, so number one, solve the inequality, give the solution set and both set builder notation, and let me move my little thingy, graph form. All right, so this is a more simpler pair of inequalities. Let me get my pins together. Okay, so we'll start with the first one. So x minus 2 is greater than 1. So we're going to solve for x. I'm going to start by adding 2 to both sides. So when I add 2 on the left, negative 2 plus 2 cancels out. And I'm going to have x is greater than 1 plus 2, which is 3. Okay, let's do the other one. So we have x plus 2 is less than 1. So I'm going to subtract 2 because I want to do the opposite of plus 2. So 2 minus 2 cancels out to 0. I'm going to bring down that x, and then we have less than 1 minus 2 is negative 1. So I have x is greater than 3 or x is less than negative 1. So that's my solution. And set builder notation. I believe it would look like this technically. You would have a little squiggly bracket, all values for h such that x is greater than 3 or x is less than negative 1. And in the graph form, let's see. So we're going to start with one number line. I'll make negative 1 over here on the left and 3 on the right. And then, now, let's start with the first one. X is greater than 3. So greater than, it's not greater than or equal to. So we're going to use a parentheses or an open circle. So I believe your book uses parentheses and not circles. So I'm going to do both. But we would use an open circle. And then x is greater than 3. All the values greater than 3 are to the right. So we're going to shade this way. If we were going to use parentheses or brackets, we would use parentheses and then shade to the right. Okay? Now, x is less than negative 1. Let's look at that one. So again, it's not including negative 1, so we're going to use an open circle. And then we're going to shade values less than negative 1. That would be to the left. And then if we're going to use parentheses or brackets, we would again use parentheses and shade to the left. Now, this is an or inequality, which means we don't need for them to intersect. So the solution would be, the green one or the red one, either or. So we can keep this as our solution. If this same problem was the same, but it said and, this would actually be no solution because and requires that they have to overlap, that they have something in common.
So with the set builder notation, would we have to write it out like that, or how you have it on the test review? We'll just have to make sure it looks like that, like how you have it written out on
It's,
the paper.
it's going to look exactly like the test review. Are you looking at
Okay.
that right now?
Yes, ma'am.
Okay, yeah. So that's why I can't stress enough
Hello?
at your test.
Okay.
So I'm gonna pull it up just so I can remind myself how it looks. But and it's kind of weird because unfortunately Blackboard isn't the best in terms of typing math stuff.
Mm-hmm.
Um, but let me pull up your test. Hold on 1 second. Um, however it is on the test is how to be on the review is how to be on the test. But let me just look real quick.
Okay.
Okay. Yeah, and actually, this is this a multiple choice question on your test
Yes.
review?
Yes, ma'am.
Yeah. Okay. For the ones that are not multiple choice, it's either going to ask you to type it in interval notation, which is a little easier to do because you're gonna, you can type a bracket, you can type a parentheses,
Right.
um, and then some do ask you to type a infinity symbol, which I believe I'm asking you to type two lowercase zeros. I mean, two lowercase O's. I'm sorry.
Okay. No, you're fine. You're fine.
Yeah, and the thing is, sometimes you guys will type, let's say, for example, you did what I just said, you
Mm-hmm.
typed two zeros, and Blackboard is going to count that wrong because it's looking for exactly what I asked for. But I always go back and check,
Mm-hmm.
and if I see that you typed two zeros side by side, and I was looking for two O's, and I know you were trying to say the same thing, I'll give you credit. So
Okay.
if that ever happens, just give me a few days to go through and check them all. Um, yeah, okay, cool.
Okay. No worries.
Alrighty, let me clear off. Okay, good. Oh, and I have two more people here. So what I'm gonna do, I'm gonna unmute you guys, and you can totally mute yourself back, but I'm gonna unmute you so that if you want to say something, you can. So go ahead and mute. There you go. Perfect. Y'all are on it. All right. Okay, let's keep the party going. Okay, number two. And I'm also going to post this video for everybody later on today. Okay, solve the compound inequality and give the solution in interval notation. So now we're going to talk about interval notation in a second. So we're going to solve this, and this is a compound inequality that's put together. So we want to isolate the x. Here's the x here. We want to get that by itself. So to start that process, we're going to undo what's around it. So the first thing we want to do is get rid of this 2, okay? So in order to get rid of that dividing by 2, we're going to multiply both sides by 2, okay? So to undo division, we're going to do multiplication. So 2 times negative 9 is negative 18, which is less than, that's canceling out this 2, okay? We just have 3 minus 2x at the top is less than or equal to 9 times 2, positive 18. All right, so now again, we are trying to get this x by itself. So we want to get rid of this 3. So we're going to subtract 3. And we want to subtract, and on the right. Okay, so now negative 18 minus 3 is negative 21, which is less than 3 minus 3 is 0. That cancels out. Bring down your negative 2x, which is less than or equal to 18 minus 3, which is 15. Okay, so now we are ready to still get this x by itself. So we're going to divide by negative 2. Now, when you are solving an inequality and you divide or multiply by a negative number across the inequality, like what we're doing right now, you must flip your inequality signs. So that means that this is going to become greater than, this is going to become greater than or equal to. All right, so negative 21 divided by negative 2, we're going to just keep that as a fraction and say that's positive 21 over 2. Negative 2 divided by negative 2 cancels out, so we just have x. And then greater than or equal to, 15 divided by -2, we'll just keep it as a fraction and say that's -15 over 2. All right. Okay, so interval notation. So the best way for, in my opinion, to do interval notation is to start with the number line. You start with a graph. So you can kind of sketch it. It doesn't have to be super duper perfect, but you want to get the point. Now, it's important to know on a number line, the farthest to the left of that number line is technically negative infinity. Because what these arrows mean is that it's going on and on forever in that direction. Same thing the other way. The right side of the number line is going towards positive infinity. All right, so we've got, let's see, put the negative number on the left, then the positive number on the right. Okay, so let's see. So this is basically saying that x is between -15 over 2 and 21 over 2. If you want, it may help you to kind of write them separate. So I'm going to take this in green. But I know we like to read from left to right, so I'm going to do is just flip it so I can read it a little better. If 21 over 2 is greater than x, then x is less than 21 over 2. All right? And then I'm going to take this. That's already written how we like it. X is greater than or equal to -15 over 2. Okay, so let's graph this. So for the green, x is less than 21 over 2. So here's 21 over 2. The values less than that are to the left. And then it's not equal to 21 over 2, so we're going to use parentheses. Okay, and we're shading this direction. Let's look at the red one. So we have x is greater than or equal to -15 over 2. So here's -15 over 2. We are including that because it's greater than or equal to. So we're going to use a bracket to represent that we are including this. And all of our values greater than are going to be to the right, going in this direction. Now, technically, it keeps going, right? So the red would keep going on this way, and the green would keep going on this way. But this is an and inequality, okay? So we only want where they intersect. So where are they intersecting? Just right here, okay? So your solution as a graph would be what I'm doing here in the black, from -15 over 2 with a bracket all the way to 21 over 2 with parentheses. Now let's write that as an interval. And the nice thing about the graph is that it almost directly matches what your interval will look like, in my opinion. So we always read and write left to right. So starting from the left, where does your solution start? At -15 over 2. Okay? And then it's going to use a bracket because we are including that value. And then the interval includes values in between -15 over 2 and 21 over 2. So we're going to use a comma and say this interval represents all the numbers from this one to this one. And then the end of our interval is going to have parentheses because we are not including 21 over 2. So your solution as an interval notation is going to look like this. Bracket -15 over 2, parentheses, I'm sorry, comma, not parentheses, comma, 21 over 2, parentheses. You didn't have to graph it, but to me, graphing it makes writing the interval so much easier. Any questions about this problem? All right, let's keep going then. Number 3, solve the absolute value equation. Okay, so for this particular one, you're going to write two different equations. So the first equation is going to be just dropping the absolute value symbols and writing it as it is. So 2s plus 2 is equal to s plus 6. The other equation is going to be the left side with the absolute value signs dropped is equal to, then you're going to do the opposite of the right side or negate the right side after you drop the absolute value. So negative times s plus 6. So again, the first one, just drop the absolute value symbols and rewrite it. The second one, the left side stays the same, but we take the opposite of the right side or just negate the right side. So on the left, we're going to just start solving it. So 2s plus 2 equals s plus 6. We want to get our s's on one side and the constants on the other side. So I'm going to subtract s from both sides because I want to move this s to the left. So 2s minus s is 1s, or just s. Bring down your plus 2 equals, then bring down your 6. Then subtract 2 from both sides. So we have s equals 6 minus 2, which is 4. Equation. Let's do the other one. So before we can start, we want to distribute this negative. So on the right side, negative times s is negative s, and negative times 6 is negative 6. Then we're going to bring down the left, and then we're going to start solving this equation. So I want to move this negative s to the other side, so we're going to do the opposite of negative s, which is plus s. Plus s. 2s plus s is 3s. Bring down your plus 2 is equal to negative s plus s cancels out. I'm going to bring down that negative 6. Okay, so now I'm going to subtract 2 because I'm trying to get my constants, my numbers to the other side. So I'm going to bring down that 3s. 2 minus 2 cancels out to 0 equals negative 6 minus 2 is negative 8. And then finally, to solve for s, I'm going to divide by 3 on both sides. So the 3's cancel out on the left, and I have s equals, and I'm just going to keep it as negative 8 over 3. So my two solutions are s equals 4 and s equals negative 8 over 3. For this problem on your test, I believe it asks for the smaller of the two numbers first, and that's just to help Blackboard grade it properly. It helps me out with grading quicker. So you would want to write the negative 8 over 3 first, and then type in the 4 for your solution. Any questions?
I have one.
Go for it.
So you know how you sat here and you stated to negate the negative onto the left side of the equation
The right side.
the right side, excuse me, sorry. So let's say it's a multiplication, how on the test you have it 1 minus 2 with the bars z minus 5 equals negative 4. For this one, would you divide negative 2 under in order to get the second solution, or I don't
Wait,
think that's a perfect example.
did you have a new, is it a separate question?
No, it's the same question that you did, number 3. So
Oh,
on
okay.
our test, yeah.
Tell me how yours looks. So I'll
Okay,
write it.
okay. So on the test is 1 minus 2
Mm-hmm.
with the bars z. No. It's after 2, not in front of the 1. So it's before the z. Yeah.
Oh, crap. Hold on. Wait a minute.
Sorry.
No worries, no worries. Hold on 1 second. So 1 minus 2z, and then
Yes.
in there, like that?
No, the bar is before the letter z.
Oh, so 1 minus 2, and then the bar, and then z?
Yeah.
All right.
So it's not in, so the bracket, the absolute value is z minus 5, not 1 minus 2.
1 minus 2.
Absolute z
Wait, tell me
minus.
again.
So sorry, it's 1 minus.
1 minus 2, absolute value z.
Minus 5. No, no, no. With the minus 5 inside the absolute.
Got you. Okay, hold on. And then,
Equals -4.
got you. All right, cool. Okay, very good. I'm glad you asked this. Before you do the two different equations,
Mm-hmm.
you want the left side absolute value to be by itself. So that
Okay.
means before we can start doing that, we want to do something with this. We want to get this by itself. So before we can do the two equations, we're going to start by subtracting 1. So 1 minus 1 cancels out. Then I have -2 times the absolute value of z minus 5 equals -4 minus 1 is -5. Now we want to get rid of that -2 times the absolute value. So we're going to divide by -2, divide by -2. So on the left, that cancels out, and I'm going to have z minus 5 absolute value equals negative divided by negative is a positive 5 over 2. Now you're ready to do the two equations. So you would basically do, I'll just do it here kind of, you would do the first one, z minus 5 is equal to 5 over 2. And then you would do z minus 5 is equal to -5 over 2. And then you would solve them each individually.
So you won't use the negative to distribute with the z to the -5, or you just leave it as is
No,
and you
you
just.
don't. Very good. You don't distribute because if this was a parentheses, you would, but it's
Oh,
absolute value, so you can't distribute that -2 into that expression.
okay.
Does that make sense? Sort of,
Yep.
kind of.
Yes, ma'am. So then you just start solving it as is to find out what the z is.
Exactly.
Okay.
And something else that I'll mention is not in these problems, but uh, let's say this said 1 plus 2
Mm-hmm.
absolute value, everything else. You still subtract the 1, and you would end up with +2 absolute value, blah, 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 equals -5. And then you would divide by the -2. You would end up with the absolute value equals a negative number. And whenever that happens, you stop right there and you say no solution.
Okay.
So this 2 right here was a positive, then that would make this right side be -5 over 2. You following me?
Mm-hmm.
So then once that happens, you say, oh, wait a minute, I can't have the absolute value of something equaling a negative number. So then that would be a no solution. And that may happen on your test. And if you do the test review enough times, like I strongly encourage y'all to do it multiple times because I have like 10 questions I have 10 versions of each question, and it's going to track your highest grade. So even if the more times you take it, the more problems you'll see that will look like what you would see on the test. And so if you say you get an 80 one of the times that you take the test review, and I don't know if y'all read the announcement, but if you get at least an 80 at any point on the test review, you will earn 5 bonus points on your actual test grade. So let's say you get an 80 the second time you take it, and you're like, woo, I don't want to do it anymore. I don't want to get anything lower. Don't think like that. It will track your highest. So even if you take it the third time and you get a 70, you still got that 80 in the bank. And then you take it another time and you get an 85. Take it again. So I want to encourage you guys to take the review as many times as you possibly can. I'm sure y'all have more other things to do, but it is the best way to prepare for your test. And you guys know your tests are weighted high, so I just want y'all to do the best you can. But yeah, I went off a tangent there. But yeah, so that's how you would solve this particular problem. And again, this is an example This was not a part of the original problem. All right, cool. Good question. All right, number 4. Now we're going to move on to graphing, and that is about how much you would have from Chapter A on your test, about 3 questions, because that was such a shorter portion of the material. All right, graph the linear equation by finding and plotting its intercepts. Okay, so intercept. So to get the, let's start with, again, what's the intercept? An intercept is where your line intercepts an axis. So an x-axis, this is your x-axis here. This is your y-axis. So if you have a line, where'd that x go? Okay, if you have a line, wherever it happens to cross this horizontal axis would be your x-intercept. If you have a line and it crosses this y-axis, wherever it crosses this y-axis is called your y-intercept. So to find the x-intercept, you want to set y equal to 0 and solve for x. So we'll start with the x-intercept. So to get the x-intercept, you make y equals 0 and then solve for x. So I have negative x plus 4 times 0 equals negative 4. All right? Because I said y equal to 0. I substituted y with a 0. Okay, so 4 times 0 is 0. So negative x plus 0 equals negative 4. So negative x equals negative 4. I'm solving for x. So I'm going to multiply or divide by a negative 1 to get that x positive. So x equals positive 4. So your x-intercept is 4, and as a ordered pair, the x-intercept would be 4, 0. All right? Because again, your y was 0, and when your y is 0, your x is 4. So if you plot that, you would go to the x-axis. You would go to 4. You can put a dot right there. That's your x-intercept. Let's look at the y-intercept. So to get the y-intercept, you're going to set x equal to 0 and solve for y. So I'm going to have negative x, hold on. So negative x, but I'm plugging in 0 in for x, so that's going to be negative times 0 plus 4y is equal to negative 4. Negative times 0 is just 0. 0 plus 4y equals negative 4. Y equals negative 4. And then to solve for y, we're going to divide by 4 on both sides. So y equals negative 1, because negative 4 divided by 4 is negative 1. So negative 1 is your y-intercept. As an ordered pair, like a point, x comma y, that would be 0 comma negative 1. So to graph that, I'm going to go to negative 1 on the y-axis and plot that point. So you only need 2 points to make a line. So I have my 2 points, and we're going to graph it just like that. So we have graphed our equation by using intercepts. Any questions about this problem?
So is it pointless to set it as y equals mx plus b?
It's not pointless at all. What's happening is that you're going to be equipped with, like, let's see, intercepts, a table, y equals mx plus b. Three different ways you could graph an equation. Sometimes for the, let me tell you. So I'm trying, for the purpose of taking this test, where I don't necessarily check your work. Yeah, y equals mx plus b could totally get you there. But if I asked for you to type in your intercepts, y equals mx plus b may or may not give you the intercepts as easily. It looks like for this one it would, because it looks like your y-intercept is -1 and your slope looks like it would be 1/4, which would end up plotting your two intercepts. But let's say your line was, I don't know, let's say you would definitely have the y-intercept. Let's say it was like here, and
Mhm.
then go to the right one. What if your line doesn't cross neatly, you know what I'm saying, across the x-axis? Then
Okay.
that's going to be annoying if I had asked you for the x-intercept. Does that make sense?
Mhm.
But for the purpose of just graphing a line, no, slope-intercept form is completely fine to use, and it's not pointless. But if
Okay.
I didn't ask for you to graph it, for example, and I just asked for the intercepts, then I would say you're kind of doing extra work by putting it in slope-intercept form. All right, so let's keep going. So here's a problem where slope-intercept form is exactly what you want to do, because it has the problem. It's almost standard form, not quite, because your x and y are flipped, but it doesn't really matter. Find the slope and the y-intercept of the line. So slope-intercept form is called that because it gives you the slope and the y-intercept of a line. So slope-intercept form is y equals mx plus b. And so I use different colors for m and b because there's a number in front of x, or the quotient, is going to give you the slope, and then b is going to give you the y-intercept. So this form is super helpful because you can get two very important characteristics of an equation super easy. And all you have to do is basically solve the equation for y. So looking at this equation here, I want to eventually get y by itself. So to start that process, I'm going to begin by moving this -4x. So I'm going to add 4x to make that go away. But if I add 4x on the left, I have to add 4x on the right. So that cancels out. I'm going to bring down my 5y equals. Now, because I want it to be in this form, I'm going to write the 4x first. Then I'm going to write -45. Because I want my equation to look just like y equals mx plus b. I don't want to say b plus mx. All right, so now to get y by itself, I'm going to divide by 5, and if I divide by 5 on the left, I have to divide everything by 5. So on the left, I'm going to have just y equals. Now, when you're talking about slope, fractions are great. No biggie, we like fractions for slope. Well, we should like fractions all the time. That's neither here nor there. So 4/5 is your slope, x, and then -45 divided by 5, that actually divides out evenly to -9. So now if you look, you should see that our equation is in the same form as our slope-intercept form. So all you have to do is match what your m is and match what your b is. So in this equation, your m, which is your slope, would be 4/5. And the b, you have to include that negative. The sign that's in front of the number goes with that number. Your b, which is your y-intercept, is -9. Any questions? All right. Okay, number 6, write the equation of a line through the given points in slope-intercept form. So, to write an equation in slope-intercept form, you have to have two things. You have to have those things that I had in the red and the blue. So we need to know the slope, and we need to know the y-intercept. We don't have either of those right now. So we're going to start by getting the slope. So you can find the slope if you have 2 points that are on the line. using what's called slope formula. So it is, you'll see it as y2 minus y1 over x2 minus x1. Do not get bogged down on the 2 and the 1. All that is saying is that you have two different points, so point 1 and point 2, and you're subtracting the y values from those points divided by subtracting the x values of those points. The most important thing is that you plug in your numbers in the same order. So for the sake of being consistent, I'm going to label my point. So the first one is point 1. I'm going to call this point x1, y1, and this will be x2, y2. But if you were to label them the other way, completely okay. All right, so, but since we labeled them, we're going to use them how I labeled. So to find the slope, let's plug in those values. So y2, the way that I labeled it, that'll be -4 minus y1, -1. Be super careful with those negatives. I've got a minus and negative, write it all down, divided by x2, which is 5, minus x1, which is 9. So now, -4 minus -1. Minus a negative becomes two positives. So -4 plus 1 is -3. Also, guys, you can use a calculator, so try not to miss easy points from, adding and subtracting negative numbers. Then 5 minus 9 is -4. And we don't want to have a negative divided by negative as our final answer. So go ahead and simplify that to say +3/4. So we have half of what we need to write the equation of the line. We have the slope. So now I'm going to find the y-intercept. So here's the deal. Your book, I believe, shows you Pointslope Form. I am going to show you that first, but I'm also going to show you a way to get this answer by using the SlopeIntercept form. And then you can use whatever method you prefer. So, Pointslope Form. It's called Pointslope Form because you need two things to use this form, a point and a slope. So Pointslope Form is y minus y1 equals m times x minus x1. So the x1 and the y1 should come from a point on your line. And so for the sake of being consistent with how I labeled my points, I'll use what we have up here. But you could totally use the other point if you wanted to. And then m is your slope, what we already found. Okay, so let's plug in our numbers. So we have y minus our y value, which is -1, equals m, which we have is 3/4, times x minus x1, which we have as 9. Okay, so let's simplify this. So y minus -1 becomes y plus 1 equals 3/4. We're going to distribute with the x, so that's 3/4x, and then 3/4 times -9 is going to be -3 times 9/4. Okay, so now 3 times 9 is -27/4. So we have y plus 1 equals 3/4x minus that 27/4. And then finally, we want to get it in SlopeIntercept form, so we got to get that y by itself. So we're going to subtract 1 on both sides. Go up this way. So y is equal to 3/4x. I need to add 27/4 plus 1. It's going to be a negative number. So I'm going to do it by hand, but remember, you do have the calculator you can use. I hate to encourage that, but I want y'all to get A's. But doing it by hand, 27 over 4 plus 1. I need to change 1 to have a denominator of 4. So I'm going to add it to 4 over 4 because 4 over 4 is 1. So 27 plus 4 is 31. And I'm going to keep the denominator the same. So my final answer would be negative 31 over 4. And it's negative because I'm adding a negative and a negative. So I add the numbers and keep the sign. I'm adding the same sign, so I keep the sign. This is my final answer here. Okay? And I said I wanted to show you another way. Let's say you wanted to use slope-intercept form. So let me see if I can scroll up. Okay, so say at this point, after we found the slope, you forgot point-slope form. Hey, it happens. If we want to use slope-intercept form, what you basically are going to try to do is to pick a point. You can use the yellow one that we have. You have the slope. You're going to solve for b, and then just go back and plug it into your equation. So this x and this y will come from the point that you chose. Your m, of course, is your slope. You're going to solve for b. So I'm just showing you another way to find the answer. So I'm going to plug in negative 1 equals 3/4 times 9 plus b. So negative 1 equals 3 times 9 is 27 over 4 plus b. I'm solving for b, so I'm going to subtract 27 over 4. So I have negative 1 minus 27 over 4 equals b. And remember, this is what I was doing over here, which ended up being negative 31 over 4. So now that you have your b, you would just go back and plug it into your original equation. You'll plug that in there. So you would write y equals, you would write 3 over 4 x, and then you would write what you got for b. So it's just two different ways to get the same answer. I don't really care which method you use. I know the book introduces point-slope form, but I feel like if there's nothing else that students remember when they leave math class, they always remember y equals mx plus b. It's the funniest thing to me. So if you remember that, you can use that to get your answer, to get your equation. All right. So again, it's just two different ways to get the same answer. You don't have to do both. You can pick one. Any questions on this one? The party going. And probably not going to get through the whole test here, but I have a video on Blackboard of me working through a test review as well. So don't feel like if we don't get through it, you can watch a video of me and a colleague doing an entire review. Okay, so write an equation of the line, write it in the slope-intercept form. So you can write the equation and I'll give you different information. You got to figure out what you have to do based on the info you're given. So again, you need two things to write the equation. You definitely need the slope and you need a point on the line. All right, so I have the point, negative 4 and 12, but I don't have the slope right away. But what I do know is that my line is going to be perpendicular to this equation here. This is important because they're telling you this because if you can find the slope of the given equation, then you will know what the perpendicular line slope would have to be. So we're going to start by finding this equation slope. So find this slope first. My handwriting on here is so sketchy. Sorry about that. I'm really trying. Okay, so to find the slope, the easiest way, probably the only way, is to put it in slope-intercept form and just grab that m. So I'm going to start by subtracting 5x from both sides. So I'm going to bring down my 7y equals negative 5x plus 63. And then I'm going to divide by 7 because I'm trying to put it in slope-intercept form. Y equals negative 5 over 7. X plus 63 divided by 7 happens to be 9. This is all good and great, but the only thing that we need is the slope. So the slope of this equation is negative 5 over 7. That's the slope of this equation that they've given us. The slope that we need is perpendicular to this. Okay? So if it's perpendicular to this equation, that means that the slope must be a negative, well, I'm going to say opposite. It must be an opposite reciprocal, which is fancy talk for flip and change the sign. So after we do that, then we're going to have the slope that we need for our equation. So if the slope of the given equation happens to be negative 5 over 7, we need our perpendicular slope to be, flip it, 7 over 5 and change the sign. So it started off negative, so our slope is going to be positive 7 over 5. If this equation was exactly the same, except that what I underlined said parallel, then we would use the same slope because parallel lines have the same slope. But it's perpendicular, so you still had to find the slope, but then we're going to flip it and change the sign. So now that we have the slope that we want to use, we have a point, so we can go ahead and either use point-slope form or use y equals mx plus b. So just curious, what form do y'all want me to use? Point slope or slope-intercept form, or you don't care?
Point slope.
Cool. All right. So let's write it out. Y minus y1 equals m times x minus x1. All right. So the x1 and the y1 is going to come from your point that is given to you. So here's x1, here's y1, and then the slope is going to be the perpendicular slope that we just found. Can you see that? Let's see. Okay, so let's plug it in. So y minus 12 equals 7 over 5 times x minus negative 4. So let's see, we have y minus 12 equals 7 over 5 times x plus 4. Now we can distribute that 7 over 5. So 7 over 5 times x is 7 over 5x. And then 7 over 5 times 4 is positive 7 times 4 over 5. All right, y minus 12 equals, okay, so y minus 12 equals 7 over 5x plus, it's going to be 28 over 5. Okay. And then we're going to add the 12 to get y by itself. So y equals 7 over 5x. And then I'm going to add 28 over 5 plus 12. So I'll do that over here in green. So 28 over 5 plus 12. I need to change 12 to have a denominator of 5. So I'm going to multiply the top and bottom by 5. So it's going to end up being 28 over 5 plus 12 times 5 is 60 over 5. 28 plus 60 is 88 over 5. So your final equation is y equals 7 over 5x plus 88 over 5. Now, does anybody want me to show you how to do this fraction work in your calculator?
Yes.
All right, give me a sec to find my online calculator. It won't take me but a second. There's somewhere I can Google it. Oh, I need to type Google. It's right there. Okay. Because, what is going on? Okay. Don't tell my colleagues, but I should be encouraging you to use your mighty minds, but I want y'all to pass. So I'm going to show you how to double check those answers. There's somewhere. Is it gone? Let's try this. There used to be somewhere I could. All right. Still there?
Yes.
Okay, sorry. I think my internet went out. Okay. I am trying to pull up a calculator. Hold on. Where's my caps on? That's annoying. I don't usually do that, gang. Oh, this is what I want. Yep. Have it. Wait a minute. I don't. Okay, let me stop. All right. My internet is being special. Since we're waiting, is the way that y'all are navigating the course, does it make sense? Like, are you
Yeah.
able to find what you need and stuff like that? Okay.
Yes, ma'am.
Good.
Yes.
Please, let me know if there's anything I can do to make more sense to you, because I know that 6 weeks is a very short amount of time. So I'm trying to make sure you can see what you need. And you won't normally just have a week to get ready for a test, but this content's probably the easier content of the course. That's why I want to get through this quick, and they have more time for you to do other stuff. So, okay, it is freezing. So,
Will we have to write it in decimal form by any chance, or is just to check to see if our answer's correct?
yeah, I rarely ask for a decimal form. If this is more to make sure you can check your answers.
Okay.
Because I just know, we get kind of nervous with fractions. So, yeah, I rarely ask. The only time I'd ask for a decimal would be if it's like application problem, like money or something like that. That
Okay.
could come up. But for this test in particular, I'm pretty certain you don't have to do that. But if you have a wrong fraction, that could throw off your slope, which will throw off, your equation and all like that. If it doesn't come up soon, then I'm going to have to just do another way. I have videos too, so if this takes forever, I'll just send you guys a video.
That works.
Hold on one second. There we go. I think I actually had it. That's embarrassing. Let's see. Now, let's see. Bingo. Okay, that's what I wanted. Can y'all see that?
Yes, ma'am.
Perfect. Okay, so and even if this is a 83 plus, I think the 84 is basically the same way. Okay, so let's say you want to find, let's do the multiplication. You want to do 7 over 5 times 4. So 7 divided by 5. I should have done this before. I like to put all of my fractions in parentheses. So I should have done that first. I'm going to say insert. Where's my insert? Second insert. Okay, 7 over 5 times 4 is going to give you the decimal, all right? But that's not what we want. The calculator will change it for you. So I want this to be as a fraction. So if it has your decimal, what you're going to press is this math button. And then you're going to choose that first option, which is fraction, enter, and then enter again. It's going to give you the fraction form. And let's say you want to add 28 over 5 plus 12. That was one we had. Again, it's going to default to the decimal, but if you want to get the fraction, just go to math, this first option, fraction, press enter, and there it is. So I know it took me forever to pull this up, but I wanted to show it to you so you could have that as a backup. And this may save you time. You know, I want y'all to have as much time as you can to do what you need to do. So that's why I want to be sure and show you that. But I do have videos posted in the course of like graphing calculator videos, but I just wanted to kind of show you that. Let me just glance and see if I can find any questions in particular that tend to give students more trouble. This is one asking you if the lines are parallel, perpendicular, or neither. You basically would find each slope using SlopeIntercept form and then compare them. So remember, parallel lines have the same slopes. Perpendicular have opposite reciprocal. And that's when I was saying, oh, I didn't mean to do that. You would flip and change the sign. All right. Okay. For problems like this, determine whether the relation is a function. Basically, you don't want your x values to repeat and to have a different y value. If that ever happens, that means it's not a function. Because if you input, say for example, 2, so you've got 2 and 2 here. And what this relation of numbers is saying, that if you were to input, because your x is your input, your y is your output. So if you were to input the number 2 into a equation, what this is saying is that it could give you a 6 or it could give you a 4. That can't happen for it to be a function. So the quick way to check this is if you have duplicates in your x's and they give you different y's, that means it's not a function. All right? Because you have duplicates in your x values. Because remember, we're talking about x comma y. If you have duplicates in your y values, that's fine, no biggie, but it's those x values you want to check for, okay? If you're given a graph, I know I'm going super fast, I'm trying to kind of touch on some stuff. If you're given a graph, you can use what's called the vertical line test. All right, So all that means, if you were to take a vertical line, which is up and down, if there is anywhere it will cross your graph more than once on that vertical line, that means it's not a function. So to pass the vertical line test, your graph must only cross that vertical line one time, no matter where you put it. So if you were to have, like if I drew it here, it only touches it one time. If I drew it here, it only touches it one time. If you were to take a pencil and go across the graph, there's never anywhere it would touch your graph more than once. Okay? So if it passes, yes, it's a function. So yes, it's a function because it passes the vertical line test. An example of a function that would fail the vertical line test would be something like if that was a graph, this would fail. No, because if you were to draw a vertical line, look here. It's crossing it here and here. So this would be not a function. All right. Let's see. Find the function value. This is function notation. This is just saying you're going to plug in 4 in for x. So everywhere you see x, you would put a 4. That would be 4 squared minus 2 times 4 minus 1, and follow your order of operations. So 4 squared is 16, negative 2 times 4 is negative 8, minus 1. 16 minus 8 is 8, minus 1 is 7. So your answer is 7. So f of 4 equals 7. Okay, domain. So to find the domain of a function, there are two major things you want to be on the lookout for: square roots and denominators. So if you don't have a square root and you don't have a denominator, like a fraction with a variable in the bottom, it's going to be all real numbers. So for example, this function does not have a square root, doesn't have a denominator. This would be considered all real numbers. So that just means real number system. To write it as set builder notation, that would look like, I think that just would look like you would say x, all values for x, such that x is all real numbers. How do I want this written actually? Let me double check that. Let me check how I want this. Number 12. Okay. On your test, it's going to give you a blank like this. This is kind of a weird way I'm asking you to put the answer, but that's the only way I could get Blackboard to grade it for me. It's going to say something like this. It's going to have a blank and another blank, and then it's going to have this. So for this answer, the answer is all real numbers. All right. So in terms of how you would write that, if you weren't using Blackboard, a lot of people literally write these words out. Some people do the little R with the 2 lines. On your test, I'm going to ask you to input something into these blanks. So if you are trying to say that the answer is all real numbers, what you're going to have to do is type in the letters A-R-N, A-R-N. And I'm totally going to have the instructions on the test. And your review looks just like it. But I just want to kind of show that to you. The next one should be an example. It kind of is. Okay. Let me make up a problem. I'm going to go to 210 if y'all don't mind, because I want to definitely show you these domain problems. I'm going to make up another one. What's the function going to be? Making this up. Find the domain. and it's f of x equals the square root of x plus 2. Okay. All right, let's say this was the question. And it said find the domain of this function. So remember I said you're looking for two different things, square roots and denominators. I've got a square root here. So just to kind of show you, I'm going to pull up that calculator again. If I were to do the square root, I gotta switch it, sorry. If I were going to do the square root of 4, square root of 4 is, oh geez, sorry, this, okay, focus. All right, the square root of 4 is of course what? 2. It's all good, we know that. If I were to say the square root of negative 4, it's going to say, wait a minute, you are leaving the real number system, and we're going to talk about what that means in about yet, but you just want to know the square root of a negative value gives you what's called an imaginary number or not a real number. So if you have a square root in your function, you want to find out the ways that you could possibly have a negative under the square root and exclude those values. That's not a part of your solution. So the best way to do that is to take what's under the square root. What's under the square root needs to be greater than or equal to 0 in order for this function to be okay. So the best way to find a domain is to set what's under the square root greater than or equal to 0 and then solve it. And once you solve it, you would have found the domain. So x plus 2 can be greater than or equal to 0. So I subtract 2 from both sides. X is greater than or equal to negative 2. That's your domain. Okay? And then to write that in as set builder, that's it right there. So we've got x such that x is greater than or equal to negative 2. That would be your answer. That's your domain. Okay, the other scenario would be, I'm going to do a simpler one than what I have right here. Let's say I have f of x equals, I don't know, 3 over x plus 2. Let's say that's my function, and I want to find the domain. So I don't have a square root, but I have a denominator. I do not want the denominator to ever be 0. If you don't believe me, let's look here. If I were to say 3 divided by 0, that is not 0. That's something that's undefined. Okay? So my domain can be all of the x values in the real number system except anything that will cause the bottom to be 0. So to find what those values would be, set the bottom equal to 0. Figure out how that would happen. Well, this would happen if x ever equals negative 2. If x ever equals negative 2, that would make the bottom 0. That would be bad. So I'm going to exclude negative 2. So my domain would be all of my real numbers except for negative 2. Okay? So how will we write that in set builder notation? That would look like all values for x such that except for when x is not equal to negative 2. So that's how we would write it, to say it's all of the x values in the real number system except for this. Okay? So those are those two scenarios. You don't want square roots and you don't want zeros in the bottom. But you don't want negative under the square root, and then you don't want a 0 in the bottom. Let's look at number 13. We don't have a square root. It's a square, but that's okay. But we do have a denominator. So you look at the bottom, x squared plus 20. Is there ever a chance using real numbers to where this would equal 0? Can this ever happen? And actually for this can never happen because anything squared is going to always be positive. All right? Anything squared is always positive. And then any positive number plus 20 is going to give you, the only way that something plus 20 could be 0 is if it was negative 20, right? That's the only way that I could add something to 20 and get 0. This in gray can never be negative 20 because it's always positive. So for this case, the bottom would never be 0, so your domain is actually all real numbers, okay? So this is all real numbers as well. But I'm really glad I showed you the 2 other examples because, you know, you could definitely have some where they aren't both all real numbers. Okay, so I gotta run, unfortunately. Okay, wait, I'll show you how to do these real quick. Okay, solve the problem. All right, so basically you've got something to where you are expressing the rate of change, which is finding the slope. And they're going to give information that you're going to put into points. So the cost of manufacturing a molded part is related to the quantity produced during the production run. When 100 parts are produced, the cost is 300. When 300 parts are produced, the cost is 1,300. Find and interpret the slope of the line representing the change. So the independent variable here is the number of parts because the cost depends on the number of parts. So your x values would be the parts and the y values would be the cost. So we're going to write these as points. So the first point would be 100, 300, and the second point would be 300, 1,300. And so now we're going to use these numbers to find the slope, and that's going to allow us to interpret how these values are changing, the rate that they're changing. So we're going to take the difference of the y value, so I'm going to just label these. So we're going to say 1,300 minus 300 divided by 300 minus 100. So I'm going to have 1,000 divided by 200, which is going to equal 5. Okay? So the average cost is, so this is saying that, this would be x. Okay. So the average cost is by, it's changing. Oh, okay, this needs to be the word increasing or decreasing. Okay, so this should be either increasing or decreasing. Since your slope is positive, it's increasing. So it's increasing by how much per part? $5 per part. Okay? So on your review, it'll tell you that it wants either increasing or decreasing. So you won't have to struggle with what I'm looking for right there. Okay. And then the other one, Laura needs to have her car towed. Littletown Auto charges a flat fee of $40 plus $2 per mile Find the cost of having a car towed 5 miles. Let's try to write the situation as an equation. So the cost, oh, I'm recording. Okay, hold on one second. The cost is dependent on the number of miles towed. So we've got, so we'll say C equals, it's a flat fee of $40. So you're going to always pay $40 plus $2 per mile. So if you just towed it 1 mile, it'll be 40 plus 2 times 1. If it was 2 miles, it'll be 40 plus 2 times 2. So the number of miles is what's changing. So we're going to make that our variable. I'll call it X. And I'm making C the cost. You could have used M, it doesn't really matter. I could have used Y for cost. So find the cost of having a car towed 5 miles. I'm going to plug in 5 in for X. So the cost is $40 plus 2 times 5, which would be 40 plus 10, which is $50. Okay? All right. This is another one. It's very similar. It's actually giving you the function. You're going to plug in the value yourself. This is another strange one that gives students problems. I'm going to go through this really quick. Use the graph of the function to answer the following questions. So, find f of -1 and find x when f of x equals -1. So this first one is asking you to find y. And then for this one, it's asking you to find x. Let's focus on the yellow one. So find f of -1. This is wanting you to find y when x equals -1. So let's go to the x-axis and go to -1. Here it is, right here. What's happening on my graph when x is -1? My y value is actually 0. Okay? So this answer is 0. F of -1 equals 0. When x is -1, because remember, this is f of x. When x is -1, what's my y value on the graph? It's actually 0. Okay, let's look at this next one. This is saying find x when y is -1, because f of x equals y. That's what function notation kind of means. So we're going to go to when y equals -1. That's right here. When y equals -1, what's my x value? It's actually 0 as well. So this answer would be 0. Okay? Now it's kind of a strange problem, but again, the best way to practice this is to do several examples when you do your test review. This, you just want to memorize those functions, memorize those basic functions, and then use the graphing calculator to graph the function. So really quick, to graph on here, you're going to use the y equals. So, okay. So we go to y equals. Oh, I should turn it on. Okay, y equals. All right, you're going to put your whatever function in here. So I want to do 1 divided by x. All of your graphs should be within the normal window. So just to see what your window looks like, you would press graph. This is the standard window here. If your window was off, like, you know, you couldn't see your graph, you could do zoom and then say standard, zoom 6, or zoom and go down to the 6th option. And that's basically asking your window to do the standard -10 to 10 on the X and the Y values. But basically for this question in your test, it would be multiple choice. You're not going to have to actually graph on your test. You would choose the correct graph for that function. And so you can put any function in here. Let's say you wanted to do x to the third. You would do x, and I'm going to do raised to the third graph, and I can see what that graph looks like. So I know I went really, really fast through the last couple problems. I know I went over time, but I wanted to just kind of show you quickly, how those could look, some tips for those. So again, you have till Wednesday to take your test in the testing center. You can use the graphing calculator. You cannot use any notes. And you have 2 full hours. So take your time, go back and check your work, and then give me a little bit of time after Wednesday to double check everyone's submission so I can check for any, typing errors or things like that. And so after the tests, I'm going to give you the opportunity after Wednesday. You'll be able to do test corrections, and I'll show you how you can access your test answers for extra credit. So that's it. Hope this was helpful. I see one person stuck with me the whole time. Appreciate that, girl. You got a question?
Yes, ma'am. Are we able to rent out a calculator from the library before we take our test?
Yes, you can. If you come to the Osceola campus, are you coming to Osceola?
Yes, ma'am.
Yeah, so come to the depot or the library, but the depot you can check it out for 4 hours.
Okay.
And yeah, just have your VID and you can check it out for 4 hours. And you can do that anytime you want to check out a calculator.
Okay, perfect. Thank you so much. This was very helpful.
No problem. So I will see you online, and thanks for working with me.
You're welcome. Have a great one.
You too. Bye.